deal with this? Okay, everybody wants to look at this and say, oh, it's x squared plus 100. That's the first thought, but that is not the case. And like I said, you have to think about when you multiply any polynomials, any multi-term things, what you need to think about is, like I said before, every term of the first polynomial must get multiplied by every term of the second polynomial. By every term of the second. Okay? That would mean this. Okay? This x, this term of this x, has to be distributed out and multiplied by both terms of that second polynomial, which would give you x times x is x squared, x times 10 is 10x. Okay, but then you also have to multiply this 10 by every term of the second one. So you end up with 10 times x and then 10 times 10. This would be your answer, except in this case it can be simplified because you have a little like term action going on. 10x plus 10x is 20x. And that is where that answer comes from. Lauren?
Those might be mixed up.
Generally speaking, we write them in descending order from the highest exponent to the lowest one. So you want to put the x squared first. Then you want to put the x. And then you want to put the one that doesn't have x. Now, with that being said, again, I'm giving you the fast whatever version here. There is a little math people like to use this. I'm not so sure it helps or not. When you have something like this, x minus 3 times x plus 8, the math people out there in the world like to use that little whatever it is, an acronym. You'll remember this, FOIL. This will ring a bell from May 15th, or not. And what that stands for is, F stands for the first terms, O stands for the outer terms, I stands for the inner terms. Why did I put an R? L, that I should have put there, stands for the last term. And this is really just for binomials. Two-term things. So for the first term, you end up with x times x, that's your x squared. For the two outer terms, that would be these two. X times 8x is, or x times 8 is 8x. The two inner terms is this. And the two last terms would be a negative 3 times 8, which is a negative 24. In a lot of cases, the two outers, the O's and the I's, can be combined because they're like terms. That's not always true, but in a lot of cases it is. So I can put these two together for my middle term. I have my x squared, I put it first because it's the highest one. 8x minus 3x is 5x, and that 24 just gets stuck down the end. Because in the real math world, really, it's very helpful if you can do this in your head. And the reason you kind of think of the FOIL thing is because eventually in your mathematical lives, you'll be given this, and you'll have to break it back down into the two binomials that would cause you to get that. So it's like factoring this down into that. Lauren?
So like you had x minus 3 y plus 8.
Okay, and then Lauren brings up really probably the next thing we should talk about, x minus 3 times y plus 8. You can still do it the same way. The thing is, nothing's going to combine. You're going to end up with 4 terms at that one. It's still the same thing. FOIL, F-O-I-L. The two first terms, though, this time are going to give you xy. The two outside terms are going to give you a x. The two inside terms are going to give you a minus 3y, this times this. And then the last terms are going to give you a minus 24. And in that case, when you have different variables starting it off, you can't combine the middles. This is all you can do, because nothing else combines. You end up with a 4-term thingamabob. Yeah.
Is this the kind of algebra we'll be doing all year? Like this binomials, basically.
All year?
Oh, most year. Algebra.
Sure, why not? This is a big thing. I can remember this back when I got a C in algebra. Nick?
So
I'm
when
not happy
do
about
we
that.
use
Blame
this?
Mrs. Clevish.
Like, when do
What?
when do like mathematicians use this?
I have no idea.
What circumstances they use this?
I'll Google that and see if I can get an answer for you on that. I just know it comes up a lot in math books. Now, looking at the problems that you were supposed to do for today, 2x plus 5 squared. 2x plus 5 squared. That was an actual problem from today's assignment. It's always best to write this out what it would really actually be. You end up with 2x plus 5 times 2x plus 5. That is the binomial times the binomial. Again, thinking FOIL, jot it down out there. What do you get for the first terms? 2x times 2x is 4x squared. The two outside terms, 2x times 5 is 10x. The two inside terms, 5x times 2x is 10x. And the two last terms, 5 times 5 is 25. Most of you had the 4x squared and the 25. You were just missing the middle term, which is 20x when you combine them. Emma Haynes.
Would it be minus 20x? Or would it be minus?
Did I write the wrong problem down? It will be for the next problem we do, if there's a minus sign. Did I write the, with the positives, it's gonna be plus. The next one in the book was 2x minus 5 squared. And in that case, it's gonna look exactly the same, except your middle terms, you're still gonna get your first term of 4x squared, except your middle terms are gonna both be minus 10x's. So yes, you will. Which brings us to the next problem, which is kind of a special case binomial thing. The next problem they give you in the book looks like this. 2x minus 5 times 2x plus 5. And if you just make a short observation there, Jeremy, you say, those are exactly the same, except the two signs in the middle. Watch what happens with this one. If you do the two first terms, you still get 4x squared. The two outside terms give you a positive 10x, and the two inside terms give you a minus 10x. And the last terms give you a minus 25. If you come up with two binomials that are exactly the same, except for the middle sign, one being plus, one being minus, the middle terms are going to drop out because they're going to end up being opposites. So you'll actually end up with just 4x squared minus 25. Now some of you might have got that right just because it happens to be that way. Yeah? Did somebody get it right just because it happened to be that way? And that would be the case there. Emma Haynes.
On our sheet it says 2x plus 5, and then 2x minus 5.
I'm not sure what you're telling me.
Or you switched it.
Oh, and it doesn't matter. I mean, this was the positive and that was the negative. If it makes you feel better.
The same thing.
What?
You just made it 6x.
Oh, I'm sorry, if it makes you feel better. Now, the only difference with that would be, this one maybe is supposed to be the minus and that one's supposed to be the plus. How's that? Alright, let me give you one here. We're on some sort of roll. What if it was just x minus 2 times x plus 6. X minus 2 plus times x plus 6. Where does the time go? It's like, where does last week go? And again, you'll get so good at this that at some point you'll just look at that and say, oh, the answer to that is x squared plus 4x minus 12. Oh, okay, well, better on. So, yeah, no, how? Don't walk in that door unless you got chocolate cake, man.
Do you have an extra flash drive I could borrow?
Extra who?
Flash drive?
You know, we as a world, wait a second, before I go on record as talking about any of this, I'm shutting this down.